Okay, let's begin part 2 to the solution to this problem involving an area of 32 square feet, and we are trying to determine the smallest perimeter possible. So I forgot to mention in the last video that given its pace, it would be an excellent idea that you do pause the video and actually start building your own spreadsheet based on this particular problem. I think you'll find it helps to cement in place some of the ideas that are being shown in the video. Okay, and at any time, if you need to hear something again, pause, rewind, reflect on what has been said, and definitely try constructing this sheet yourself using Microsoft Excel or some other spreadsheet software. Okay, so we just finished determining some formulas for both the rectangle number and for the width of the rectangles. And we also determined the length and perimeter for our first rectangle. So it follows that in this cell here, that we would need a formula that would calculate the length given the width and the area. So just take note that our formula here, okay, for the length happens to be 32 feet. Okay, which makes sense. If you take the area and divide it by 1, you'll end up with that amount. In this cell here, what we're going to do is we're going to enter a formula in. We're going to take that particular area or that particular cell, which is, use the dollar sign again, E2. Okay, and by doing that, we set the area as a constant. And I'll show you what that means in just a moment. So we're going to divide the area by the width, which in this case is cell number B3. And you can see it being highlighted, and we'll press equals. So that makes sense because 2 times 16 does give 32, which is the area. The perimeter, on the other hand, and using a formula, is going to be twice the width plus the length. So we're going to take 2 copies of the width, which is cell B3, and to that we're going to add 1 length, which is cell C3. And there we have a perimeter of 20 feet. Okay, so you can already see that by doubling the width, although the length is reduced, so too is the perimeter. Now for me to have to add formulas to each of these cells would really defeat the purpose of using a spreadsheet. So what we're going to do is I'm going to click on this cell, that is C3. I'm going to bring my cursor to the corner. I'm going to click and fill down. And what you're going to notice is that the cells automatically fill in with their corresponding lengths. Now recall the formula we had here. We use these dollar symbols around the letter E and then divide it by the width. As I cursor down, you're going to notice that that E2 cell stays constant throughout. So we're always referencing that area amount. The amount of area that's in cell E2 is being held constant. The only thing that's changing is what we're dividing by. That is the width. Okay? So if we can do that there, I think it would make sense that if we highlight this cell and we fill down, we're also going to come up with the corresponding perimeters. Okay? Just to verify, as you cursor all the way through, you can see how the formulas correspond specifically to the widths and the lengths for the rectangles that you are specify. Okay, so at this point in time, what we're going to do is we're going to actually begin answering part A. So here we go. For a three-sided rectangular balcony with this area, what is the smallest perimeter possible? So as we cursor our way through the table, you'll notice that 16 happens to be the smallest perimeter possible, and we'll just highlight the dimensions as well. I'll just put a different color on there. So a width of 4 and a length of 8. These dimensions produce a perimeter of 16 feet. So both questions A and B have been answered. Okay. Lastly, part C says, what is the relationship between the length and width for these types of enclosures? Well, I think it does become plain to see that twice the width, that is 2 times 4, gives us a length of 8. So we could say that for part C, if we double the width, we're going to produce the length. And this is specific, as we saw earlier, for our three-sided rectangular enclosures. Okay, so that concludes this short video. Again, please go back, construct your own sheets, and ensure that you do have a handle on how to do this. In the next video series, I'm going to offer you or present to you a practice problem. We'll have you try it out, and then you can check your work by watching the video.